In chapter 4, we have two more quadrilaterals that we have to talk about, the trapezoid and the kite. So we'll start with the trapezoid. A trapezoid is a four-sided figure, a quadrilateral, where you have exactly one pair of parallel sides. If you think about all the other shapes that we've talked about, the parallelogram, the rectangle, the rhombus, and the square, they all had two sets of parallel sides. Both sets of opposite sides were parallel. So the trapezoid is different because it only has one pair of parallel sides. Now, the trapezoid's special. The sides all get special names. So if you look at the picture here, the sides that are actually parallel are sides BC and sides AD, and they're blue in this picture. Those blue sides you can see have red arrows on them. We should remember that those red arrows are parallel markings. So sides BC and side AD are called our bases. The red sides are called our legs. Those are our non-parallel sides. So our parallel sides are our bases and our non-parallel sides are our legs. We can also talk about the angles of a trapezoid. The angles that run along the base. So again, if you look at that picture and look at one of the blue lines. So if you look at the top blue line, BC, line BC that's blue, has two angles, right? It has an angle B and an angle C along its ends. Those are called base angles. And you can do the same thing with the bottom base. The bottom base was line segment AD. It has base angles A and D. And we're going to learn some properties about the base angles in a minute. But right now we're just trying to talk about how to name the parts. So all of that is in this paragraph over to the side. But one thing that the books do not talk about are what I like to call leg angles. So they don't really call them leg angles, but leg angles are also important because we're going to learn some properties about our leg angles. So I like to call angle A and angle B. We're going to call those leg angles. And again, this won't be in any book, but it'll be helpful to talk about them later. And angles C and D are another set of leg angles. All right, so our sides are going to be called our bases and our legs. Our bases are going to be our parallel sides and our legs are going to be our non-parallel sides. And then our angles are going to be either called base angles or leg angles. Our base angles run along our bases, which are blue, and our leg angles run along our legs, which are red in that picture. Now, we could have an isosceles trapezoid. If the legs are congruent, then we have an isosceles trapezoid. So you can see in this bottom picture where we say isosceles trapezoid, we have tick marks on our sides, right? We have those red tick marks. So those red tick marks are trying to tell you that the legs are congruent. Remember, the legs are the non-parallel sides. So those are the ones that are congruent in an isosceles trapezoid. So that's just some vocabulary related to trapezoids. Let's talk about some properties. So these first three pictures are supposed to be for isosceles trapezoids only. So isosceles are special because some extra things become congruent in an isosceles trapezoid. So for isosceles trapezoids only, our base angles will be congruent. So remember, our base angles run along our legs, right? So you can see the way they're marked, hopefully, but angle B is going to be congruent to angle C. Notice the markings are the same. And angle A is going to be congruent to angle D. Those are our base angles that we're talking about. B and C are one set of base angles, and A and D are another set, and they're congruent to each other. Now, we could use this backwards. If we were going to do proofs, we would use what we call the converse. Hopefully you remember that word converse from chapter 2. If we were doing proofs, we could use the backwards of that original statement and say that if we knew the base angles were congruent, then we know we have an isosceles trapezoid. Since we're not going to be doing proofs, we really won't need that middle property. All right, and then finally it says if you have an isosceles trapezoid, then the diagonals are congruent. So remember the diagonals are always the lines that are running from corner to corner. So in this picture, that's trying to tell you that AC is congruent to BD. So for isosceles trapezoids, your base angles will be congruent and your diagonals will be congruent. Now, the reason I wanted to name the other angles the leg angles is because for any trapezoid, for all trapezoids, our leg angles are actually going to be supplementary. And think about why that is from our parallel lines chapter. Whenever you had parallel lines and a transversal, these angles on the inside right here were called same side interiors. So in any trapezoid, you actually have same side interior angles running along your legs. And so we should remember that those are always supplementary. So in our pictures on this page, all the leg angles are labeled the same. So let me first write that leg angles are supplementary. And that means, again, run along your legs, your non-parallel sides. That means the measure of angle A plus the measure of angle B will equal 180. That's one set of leg angles. The other set of leg angles would be C and D, so the measure of angle C plus the measure of angle D will also equal 180. And again, that should tie back to our chapter on parallel lines and transversals. And of course, for all trapezoids and for any four-sided figure, measure of angle A plus the measure of angle B plus the measure of angle C and the measure of angle D will equal 360 degrees. Anytime you're adding up all the angles in any quadrilateral, they will add to 360 degrees. All right, so all trapezoid have leg angles that are supplementary. All trapezoids have all the angles adding to 360. But if you have your legs being congruent and therefore you have an isosceles trapezoid, you'll have base angles being congruent and you'll have diagonals being congruent. All of these properties are on our flow chart. So we've talked about that flow chart quite a bit. I didn't put it in this set of notes, but on our flow chart you would see all of these properties listed. All right, so in example 1, it says find the angle in question in each of our trapezoids. So what you have to ask yourself, am I dealing with leg angles or am I dealing with base angles? Now, none of these pictures have the parallel markings on it because the software we're using doesn't put them on there. So let me add them. We should really know that we always have one set of parallel sides. So I'm going to put those arrows, even though the software doesn't do this for us. I'm going to put those arrows on our parallel sides. So remember, the angles that are running along our parallel sides are considered our base angles, and the and the angles running along the non-parallel sides are considered our leg angles. So our base angles in an isosceles trapezoid will be congruent, and our leg angles in any trapezoid will be supplementary. So in example 1A, angle U and angle R, and I'm looking at those because U has a question mark and R has a 55 degrees on it. Those are running along one of the parallel sides, right? They're on the ends of one of the sides that has an arrow on it. And so these are our base angles. And so I should know that base angles are always congruent. And so the measure of angle U must also be 55 degrees. If we look at the next picture, the question mark and the 60 are running along our leg, right? Our legs are going to be our non-parallel side. So the question mark is on L and the 60 is on K. That line segment LK is not parallel to anything, and so they're going to be supplementary. So the measure of angle L is going to be equal to 180 minus 60, which is going to equal 120 degrees. So we have base angles in A, we have leg angles in B. There's a difference, right? The base angles are congruent, the leg angles are supplementary. If we keep looking here, in C, we have again some leg angles. It's running, our question mark's on V and our 35 is on W. That's running along our on one of our legs. And notice this one's not isosceles, but it doesn't have to be, because if you go back above, all trapezoids have leg angles that are supplementary. So I don't have to have those tick marks on the side to talk about my leg angles. I only have to have those tick marks on the side if I want to talk about my base angles. So in this one, the measure of angle V will be equal to 180 minus 35, because again, those are supposed to be supplementary. So we have 145 degrees for angle V. And finally, angle M, if we look at angle M and compare it to angle L, that's running along one of the sides that has an arrow on it. So it's running along our parallel side, which means those are base angles. Base angles are congruent only in isosceles triangle or trapezoid, but luckily we have those tick marks on the side, so we know we are dealing with an isosceles triangle, trapezoid. So the measure of angle M will be equal to 145 degrees. So there's really no way for me to ask you about the base angles unless we're dealing with an isosceles trapezoid, because if we were dealing with a regular trapezoid, a non-isosceles trapezoid, then the base angles are not congruent and they don't actually follow any pattern. So whenever I ask you about base angles, you should be looking at an isosceles triangle. But whenever I ask you about leg angles, it could be any, I keep saying triangle, sorry, trapezoid. But anytime I talk about the leg angles, I can give you any trapezoid. All right. All right, in example 2, I'm looking at diagonals. Now, if you went back up above and look at the properties that have to do with diagonals, there's only one place I talked about diagonals, and that's right here. Well, diagonals are congruent only in an isosceles trapezoid. When I talked about all trapezoids, I never mentioned diagonals. So I have to have those little tick marks on the side if I'm going to ask you about the diagonals. And so notice in example 2A and in example 2B, the legs actually do have tick marks on them. So in this example, these are definitely isosceles trapezoids, which is good because otherwise we really can't talk about the diagonals. All right, example 2A, it says LN is 24. And I've talked about this before. I like to see exactly what is 24. So for me, I would like to put that 24 on there. And that's what is 24, all the way from L to N. What they want me to find is from K to M. Well, because I know the diagonals are congruent, I know from K to M is going to be exactly the same as from L to N. The diagonals are congruent, so they're both 24. To make it a little more complicated, we could look at something like example 2B. So RT is 24.1. So if we go and put that on the picture, RT is 24.1. And then they're telling you QP is 9.6. So from Q to P, I have 9.6, which is getting a little messy in here. Well, half a diagonal is never going to be equal to a whole diagonal. So obviously 9.6 doesn't equal 24.1. And let's see what they really want us to find anyway. Let me highlight this in green. They said to find PS, and PS is from here to here. So what I know is from R to T will be the same as from Q to S, right? But I don't know Q to S, right? I'm missing part of it. So let's call that X. I do know RT. RT is 24.1. QS is made up of a 9.6 plus some missing piece that I don't know, 9.6 plus X. And so all you'd really have to do is subtract the 24.1 and the 9.6 to figure out what X is. And you would get 14.5. And that is exactly what they asked you for. Our X was our PS, right? So our answer is 14.5. You really just had to subtract them. Just though, as a reminder, don't really look at a problem and struggle with it unless you mark up the picture. If you mark up the picture, it usually helps you figure out how to find your missing piece. So putting those labels right on the picture, I think, is very helpful. All right, so that's what we know about diagonals, is that they're congruent to each other, and maybe it'd be as simple as something like 2A, or maybe you'd have to do a little bit of subtraction like in 2B. Okay, so that's everything about trapezoids. We know if it's isosceles, our base angles are congruent and our diagonals are congruent. But if it's not isosceles, any kind of trapezoid, we can say the leg angles are supplementary and that all the angles add to 360. So let's move on to kites. Kite is another four-sided figure, so of course it's a quadrilateral. And this time, all it says is it has two pairs of consecutive congruent sides. Remember, consecutive means right next to. The other way we could talk about sides is talking about opposite sides. So we either have opposite sides or consecutive sides. So consecutive sides are any two sides that are next to each other. So a kite, they don't say anything about parallel, right? This is the first time they haven't mentioned the word parallel. So we know parallelograms have two sets of parallel sides. We just learned that a trapezoid has one set of parallel sides. A kite doesn't have any sets of parallel sides. And what it actually has is congruent sides that are next to each other. So that's the first time that's happened, that the congruent sides were actually next to each other. So in this picture, you can see that you have some tick marks. You have a single set of tick marks, and those are two sides that are next to each other. And then you have a double set of tick marks, and those are also next to each other and not opposite from each other. What else is special about a kite? So what else is special about a kite is that your diagonals are perpendicular. So notice in this picture here, they threw in those blue lines in the middle. And again, when you go from vertex to vertex and put those lines through the middle of a shape, you're creating diagonals. And so see the box in the corner, right? They put the box in the corner to show that the diagonals are meeting at a right angle. So that's one thing that's special about kites. Another thing that's special about kites is that one pair of opposite angles is going to be congruent. And so that's not super helpful. What do they mean about one pair? It's actually the pair that are both between the non-congruent sides. So if you look at the angles that are between the non-congruent sides, so angle C is between a single tick mark and a double tick mark, go find the other angle that is between a single tick mark and a double tick mark. Those are the two angles that are going to be congruent, okay? And so if we were in class together, I'd probably talk about flying a kite. Anybody who's ever flown a kite and bought a kite in a package, there's always this stick that you have to put in, and the stick gets put in right between those non-congruent, in between the non-congruent sides. So it gets put right between those congruent angles, but that's only if you've ever flown a kite. All right, so what kind of questions might we ask about a kite? In example 3, it says WXYZ is a kite. So we're looking at a kite over to the right, and it says XY is 5. So let's put a 5 on the picture right where XY is, and WZ is 13. So we'll put a 13 here. They want you to find the missing sides, which hopefully is easy given the way the markings are, but also given that we know that in a kite, you're going to have two sides that are next to each other that are congruent, and then a different set of sides that are next to each other that are congruent. So our missing YZ, if we ask what YZ is, it's going to be 5, just like XY, right? It's going to be 5. And then WX is the other thing they want. That's going to be 13, just like WZ was. So WX is going to be 13. So you always have the sides matching up like that. The ones that are next to each other will be the same. So that's 2 of the answers. And then the final thing they ask is, what's the perimeter? So hopefully by now you remember that perimeter is the distance all the way around a shape. So all of the shapes we've been talking about are quadrilaterals. So I should be adding up all 4 sides, and I would get the 5 plus the 5 plus the 13 plus the other 13. If you add up all of those numbers, you are going to get 36. So our perimeter is equal to 36. All right, so that's something they could ask about a kite. They could ask about its perimeter. Another thing they could ask about a kite is help us find the missing angles. So if we look at example 4, it says find the measures of the missing angles. Well, it's a 4-sided figure, so there's 4 angles. So the angles I'm missing are E and G. What I know is E and G are the angles that are between the non-congruent sides, so they're going to be the same. Remember, there's always one set of angles that are congruent, and so we can give them the same variable. So I'm going to give them both an X. And now, hopefully, if you looked at this picture and said, every single angle in this quadrilateral is marked with something, and so I could always add them up. Anytime you know all the angles in a shape, you can add them up, of course. So if you add up the 2 X's plus the 100 plus the 40, what would they be equal to? Well, quadrilaterals always equal 360 degrees, right? So that gives me 2x plus 140 equals 360. If we subtract the 140 from both sides, we're going to get 2x equals 220. And if we divide by 2, we'll get x equals 110. And x is the measure of angle E, which is the same as the measure of angle G, right? They're both equal to x. And so we know they both equal 110 degrees, both of my missing angles. And finally, they threw in the diagonals in example 5. And let's label what they've given us. They said SRT is 24 degrees. So remember, if you don't know what that is, trace it. If you went from S to R to T, where those two red lines meet, that is 24 degrees. That's pretty hard to squeeze in there, so I'm going to point in there. That is 24 degrees. They also told you TSP is 53. So again, if you don't know where that's at, go ahead and trace it. Let me pick a different color. From T to S to P, where those two purple lines meet, that's going to be 53 degrees. And so I don't know about all four angles, right? It's not like I could add everything up to 360 because I don't know anything about P and Q. I do know angle Q and angle S. The entire angles would be congruent. I do know that. But that's not really going to help me because I don't know the entire angle S. So what happens when you throw in, excuse me, the diagonals? You create all these triangles, right? You've just created 4 little mini triangles inside of that kite. And what's true about these triangles, let me number them. So triangle 1 and triangle 2, those are congruent. Those are exactly the same size. Triangle 3 and triangle 4 are exactly the same size. I also know up above that my diagonals are perpendicular. So I can throw in some 90-degree angles in all of these triangles, right? I can put all 4 of these triangles have a 90-degree angle in them. And so what did they actually want? They wanted me to figure out angle SPT. So I'm kind of running out of colors here, but not really running out, but it's getting kind of messy. If I go from S to P to T, let me do that in green right now. That's the angle they want. They want this green angle right there. And so if I focus there, it's got a 90-degree. If I focus, let me highlight the whole triangle in green. The whole triangle there has a missing angle P. It has a 53 degrees and a 90 degrees. So if I call SPT X, I can take X plus 53 plus 90, and I'm just focusing on that little triangle that got created on the inside of that kite. That's going to make 180 degrees. So if I add up the 53 and the 90, I get 143, plus here, equals 180. And if I subtract the 143 from both sides, I'll get x equals 37 degrees. And x was what I was calling the measure of angle SPT. All right. So if they throw the diagonals inside of a kite, you're creating 2 different sets of congruent triangles. And we should always remember that triangles add to 180 degrees. So maybe we can use an old fact that we learned about triangles to help solve this problem. Now I had meant to add one more angle. I also want you to find in this problem the measure of angle RST. Should add that to the notes eventually. I totally forgot. So if we look down at RST, and again, if you were going to trace it, it would be this purple one right here, right? That purple angle I just highlighted. And so again, if you focus on triangle 3, let's call that one Y. We have a missing Y, we have a 90 degrees, and we have a 24 degrees inside of that red triangle that has that purple highlight in it. And so Y plus the 90 plus the 24 will make 180 degrees. So Y plus 114 equals 180. If we subtract the 114 from both sides, we get 66 degrees. All right, so that's just kind of tying in an old concept inside of the old concept being that triangles add to 180, tying that into a kite. What's really more important to me is that you understand how to do examples 3 and example 4. Now, if we look at our flowchart one more time here, again, we see that there are 20 properties. We have focused in this lesson on the right side of this flowchart. We've looked at kites, we've looked at trapezoids, and we said that there's special kind of trapezoids when the legs become congruent. All the properties we've talked about are listed. So for trapezoids, again, it says if you had one pair of parallel sides, 11 through 14 will be true. If you know your trapezoids isosceles, 11 through 14 is true, but so is 15, 16, and 17. And these are all things we talked about in the notes. If we go to a kite, we do not have any sets of parallel sides. Notice it says there's no parallel sides. And the only thing you can really say about a kite are 18, 19, and 20. And of course, don't forget that I talked about this in today's Zoom session, that the sum of all of these shapes is going to be equal to 360, so that could help also, okay? And finally, I just want to mention in this that we're not going to talk about mid-segments, so 13 and 14 are never anything that you're going to have to know. All right, so that's our last two shapes, which are trapezoids and kites.